So today I am going to discuss our Laboratory 7 with the title Interfacing Liquid Crystal Display or LCD with Arduino Uno board. So today, as you can see, we have here a cover page with a photo, peace, love, and code. So as we go on this laboratory, you will know what this picture is about, and why it is there. So the duration of this laboratory, including the whole laboratory itself, is 3 hours. So let's start with the objectives. The objectives of this laboratory are to introduce the student to Arduino Uno hardware, Arduino software, writing, compiling, downloading, and testing programs to control LEDs using digital outputs on the Arduino Uno. Lastly, interfacing various devices such as LEDs, switches, and piezo buzzers. So let's move on to materials. So here are the materials that we will need. You can read or pause the video if you want to read all the materials that we will need. Okay, let's proceed with the introduction. In this digital age, we come across LCDs all around us, from simple calculators to smartphones, computers, and television sets, etc. The LCDs are liquid crystals to produce images and text, and are divided into different categories based on the different criteria like type of manufacturing, monochrome or color, and whether graphical or character LCD. In this tutorial, we will be talking about the 16x2 character LCD modules. The 16x2 LCDs are very popular among the DIY community. Not only that, but you can also find them in many laboratories and industrial equipment. It can display up to 32 characters at a time. Each character segment is made up of 40 pixels that are arranged in 5x8 matrix. We can create alphanumeric characters and custom characters by activating the corresponding pixels. You can easily interface a liquid crystal display or LCD with an Arduino to provide a user interface. Liquid crystal displays or LCDs are commonly used to display data in devices such as calculators, microwave ovens, and many other electronic devices. So, for this introduction, we've learned that LCD this liquid crystal display is a display. As the name suggests, it is a display device that displays a user interface. So we can proceed. Here are the parts of the 16x2 LCD display, by the way. You can pause the video. And here are the explanation for each of the parts. Okay, so go on. So these are additional information about the LCD. So since the focus of this video is to provide or to demo the laboratory itself, we will not be diving deep into this extra information about the LCD, but you can pause the video to read and analyze the additional information for the LCD. Okay, so this one is a schematic diagram. This procedure is a test code for the liquid crystal for the LCD. That's the liquid crystal this one is a liquid crystal library. So as here indicated here in the procedure, this example sketch prints a hello world to the LCD and shows the time in seconds since Arduino was reset. So you can try it yourself. And for this laboratory, we will now go to the lab task. So first is we have here the program 1, Peace, Love, and Code. Create and design a display showing the graphics found at the cover page of this experiment handout. So a while ago, at the beginning, I've mentioned the cover photo, and you can see there we have the Peace, Love, and Code there indicated display in the LCD. So that is what this program 1 will be all about. So now I'm going to demonstrate the program 1. Okay, so we have here, so this is the LCD and our Arduino Uno, and it is now connected. I am going also to show the code that we've used. So this is the code. Okay, and also the schematic diagram. So this one, since it is only a program 1, it's pretty simple and straightforward. So now we can start with the simulation. Okay, yes, you can see we have here Peace, Love, and Code exactly as instructed on the laboratory 1. Now we can proceed with our program number 2. Program number 2, Marquee Message. Create and design a message marquee system. The program will be controlled by 2 Light-Dependent Resistors or LDRs in displaying the 2 marquee messages. That is, if the left LDR has sense, it will display the marqueeing message from left to right direction. The message will be "Welcome to PUP CPE department." Otherwise, it will display the marking message "Goodbye, see you again next time," from left to right direction. So in this program number 2, in simple terms, we will have 2 light-dependent resistors which will control the marking message. So if the left light-dependent resistor is sensed, the LCD should display the message "Welcome to PUP CPA department," and otherwise, or it will display the "Goodbye, see you again next time." Okay, now we can proceed with our program number 2. So as you can see, our program is, as we go on this laboratory, our program is getting complex and complex. So as it should. So we have here the Arduino Uno, the breadboard, of course, some resistors, wires, and these are LDRs or light dependent resistor, and we have here the LCD. So I will show you the code for this. This is the code that we've used, and then this is the schematic diagram. So now we can proceed with simulating the program number 2. Okay, it's on now. You can see the LCD. So let's start first with the left LDR. Okay. As you can see here, as the left LDR is sensed, the LCD display "Welcome to the PUP CPA department" as instructed on the program number 2 of this laboratory. Okay, now let's try with the next LDR. "Goodbye, see you again." Okay, next time. So with this second LDR, the message displayed from left to right is "Goodbye, see you again next time," as also instructed from our laboratory. So good job with us. We're able to represent the needed information from our program number 2. We can now proceed with our program number 3. Program number 3, a decimal calculator. Create and design a decimal calculator that can perform the following mathematical operations such as addition, subtraction, multiplication, and division. The mathematical expression formed from typing it via the keypad is being displayed over the LCD as well as the output of the said mathematical expression. So this program number 3 is all about calculator. So that's the simplest explanation to it. So we have to design a calculator using the LCD and a keypad. So now we proceed with our program number 3. So it is complex compared to program number 1 and 2, of course, but it is, we can say that it is pretty much understandable on this program number 3. We have a keypad. This will serve as our input, or this is where our input will be coming from. And then we have the Arduino Uno connecting it with the LCD. The LCD will display whatever input we will be inputting from our keypad, I mean. So let's proceed. I will show you the code that we've used. So keep in mind that this will be a calculator. Okay, I'll also be showing you our schematic diagram and we can proceed. So the objective here is to have a calculator using the following materials that is present on the screen. So let's start with the simulation. Okay, so you can see we have a display here of decimal calculator. So let's start. Keep in mind that the operations will be A will be addition, B will be subtraction, C will be multiplication, and D will be division. So let's start. Simplest one, 1 plus 1. Okay, we have here 2. And also this asterisk can be used to clear what's on the LCD. Let's try with subtraction. So 3 minus 1. That's 2. That's great. Let's try multiplication. 5 times 5. Okay, that's 25. Lastly, we try with division. Okay, as you can see, our calculator works and it serves its purpose with the correct information. We use the keypad to input the numbers and also the operation, and then the code. The code, we cannot see the code here, but the code is also important, of course, because it is the one processing the input from the keypad, and then after that the LCD will display the result. Okay, program number 4, password-driven piezo buzzer. Design an Arduino circuit for password-driven running LEDs. The program will ask the user to enter a password through the keypad. If the password is correct, it will buzz off a correct musical tone of your choice, and the running LED will light from left towards right. Otherwise, it will display the incorrect running LED's pattern of your choice, together with the sound off from the buzzer. Different tone from the correct password, of course. And as again, the user to enter the correct password provide 3 trials for entering of the correct password. At the last attempt, if still the password is incorrect, Arduino will disable the keypad. That is, it will no longer be accepting any entering of password. It should display the corresponding prompts such as enter your name, enter your password, access denied, attempt already, welcome, then the name. You can set some prompt in blinking effect. So the instructions here are long, but basically what we will be having is like a password driven Piezo Buzzer, basically. So we will be using LEDs and then for the a Piezo Buzzer. What will happen here is the system or the LCD should ask for the name and also the password, and then if the password is correct, it will produce a certain sound and also a certain LED pattern. And then if the password is incorrect, it will give you another chance to enter the correct password, but it will produce a certain sound different from the sound from which if you got the correct password. So to further understand, we can now proceed with our program number 4, and it's the demonstration. So we have here the keypad, the buzzer, the LEDs, the resistors, some wires, and also the LCD. So I will provide you, or I will show you the code that we've used for this. Okay, here it is. And also I will show you the schematic diagram for this program. Okay, here it is. We can start by simulating this program. Okay, as you can see, here's the prompt as instructed or requested on our laboratory. So first, let's try. So let's assume this is the name. So we will now enter the password. So for this time, we will enter a wrong password. You can see access denied attempts 1. So as instructed on our laboratory, it should only be there should only be 3 attempts, and after that the keypad will be disabled. So for our second attempt, we will try to use the correct password. Okay. As you can see, if the password is correct, it will display welcome, and then the name that you've used, and there's a sound and a pattern from the LEDs. So now we have so far all of the required functionality of this password driven Piezo Buzzer is fulfilled, except for the after 3 attempts it should disable the, or after 3 wrong attempts it should disable the keypad. So that's what we will be trying. That's 2. Access denied attempts 3. Keypad disabled. Let's see if it is really disabled. Okay, as you can see, we cannot use our keypad. So that's great. So all of the purpose of this program is served, and we can now proceed with our program number 5, and also this is the last DIY LCD keypad video game. Create your own LCD keypad video game. You can include tone rendition as you play the game. So for this program number 5, we are given freedom to create our own LCD keypad. So this will show how creative you are if you are doing this program. So let's proceed with what we've programmed for this program number 5. Okay, as you can see here, we have a keypad, the LCD, and other familiar factors or tools. So here's the code that we have and the schematic diagram. So I'll explain first before we start simulating. So this game that we have is you have to guess the number, and the LCD will be displaying a prompt if you got the number or not. And also we have some hints here. So let's proceed to further understand. So here's the prompt, guess the number. If you enter a number, let's say number 2, and then we enter too low. So we have to make it higher. It's 36. Too low. Okay. So I think if you're playing this game, I think one of the pattern or strategy that we can use is to get the numbers by after the 9. Let's say 10, all the numbers divisible by 10, 10, 20, so we could have a range. It's still too low. Too low. If we try something that's really high, say 1000, so that's too high. So basically what this program do is just a game where you have to narrow down the numbers or the digits that you have to enter or to guess the number, to guess the correct number. So that's the game that we have for our program number 5. It's laboratory 7. So that's the last program here. I hope you enjoyed this video, and also you've learned how LCD can be used in many ways all throughout from program number 1 to program number 5. So thank you very much and have a great day.